Hi friends, this is Rakesh, and today, as requested by one of the viewer, I am going to show how to apply nodal forces at an angle, right? For that, first of all, what I will do is I have created a small beam and I have fixed this support, right? I have fixed this support, and now what I have done is I am going to create a coordinate system. So for that I will click on the coordinate system, go insert coordinate, new coordinate system, and just rename it as angle. Rename it as angle, right? And here instead of geometry specification, you go for the global coordinates as a reference, right? Global coordinates as a reference, and see, the new coordinate system aligns with the global coordinate system, but I want it at an angle. So what I will do is I will rotate this newly created coordinate system about x, right? For that, what I will do is I will select this rotate about x, right? And I will give the angle somewhere around like minus 35, right? So what happened is it has rotated about 35 degrees in the anti-clockwise direction, right? So now I have created my required angle. Now next, go for neighborhood selection. You have to create a neighborhood selection of the nodes which you are interested to apply the forces on. For that, what you will do is go for mesh selection instead of geometry selection, and then you select the nodes of your interest. So I am selecting the nodes here which are present at the end of this geometry. Okay, and I say right click, say create neighborhood selection, and I give some name like nodes, right? Press OK. Now we go to the static structure. First of all, what you have to do is you have to put nodal orientation. You have to create a nodal orientation. Otherwise, what happens is if I say, right, for example, if I go to directly FE and say nodal forces, and in the neighbor selection I will select the nodes and I will give somewhere around 15,000 newtons in the Z component, means it will be acting in the axial direction. So first of all I will solve and show you how the deformation effect will be there, right? So total deformation, see the total deformation is in this downward direction, because what happens is it is at the tip of this force is acting in the axial direction, and below this no force is acting, so it tends to rotate there, right? Now I am going to apply the same force at an angle, and I am going to show you the deflection direction, right? For that, what I will do is first of all I will suppress this one nodal force. Then what I will do is for applying at an angle, you have to first put the nodal orientation. For that, go for director field and select nodal orientation, right? And from the neighbor selection you click on this nodes. So I want only assign the orientation to that particular nodes in the neighbor selection, and instead of global coordinate system you will select angle coordinate system, right? So you have created the nodal orientation. Now what you will do is go for director field, then go for nodal forces, right? The neighbor selection, select the nodes, neighbor selection nodes, and you press 15,000, you just enter 15,000 here, right? And you just solve the problem. Right, and now see the the deformation direction is upwards, right? Because what happens is at the tip it is acting at an angle, so it tends to go upwards. The deflection will be in the upward direction, right? So this is how you can apply forces at an angle at nodes. Even if you want it, you can also apply it to any geometry, these angles to any geometry, equal entity like lines and everything. So for that, what I will do is I will just suppress this too. And now what I will do, I am going to apply a line force at an angle of 35 degrees. For that, what I can do is I can go for static structure, say insert, say some force, right? Force, yeah, this is the force, right? So instead of vector, what I will do is I will put the components there. And here, when you put the when you select the option defined by components, you will get a coordinate system. So I want the angle coordinate system because I want to put it in angle of 35 degrees. So for that 35 degrees, and I just give 15,000 newtons, right? 15,000 newtons. And for the geometry selection, I'm going to select this line, right? This particular line. Say apply, and now say solve, right? Okay, and you can see the deflection direction, right? Okay, this is a vector display, that is why you are getting arrows. You can also see the counter display also, right? You can also see the counter display if you want. So thank you friends, hope this helps you, and thank you.